Hi, this is Bernhard Wiemann, and this is the fourth part of the TORCS car creation tutorial. In this part I will show you how to bring the model we have created in the previous tutorials into TORCS. Okay, let's start with borrowing some more files from car1 stock 1. This is the shadow, the wheel texture, the readme, and the car1 stock 1.xml. This is the physical car description. By the way, do not forget to make backups of the whole thing here and then in case you screw everything up. Now we have all files we need, so we can finally get rid of the car1 stock 1 directory. As next step, I copy the ACCC and stripe utility from the torx directory into our working directory. This is not required under Linux because the files are there usually in the path. As you will see, you will never execute the stripe utility manually, but ACCC does call it internally. Okay, we got it, so we are ready to process the cartut.ac file with ACCC. A comment to the ACCC tool in 1.3.4. It has still a bug in it which makes it impossible to process objects which just consist of one or two triangles. If it hits such an object, it will crash. You can fix this with adding additional vertices to such objects or merge the objects into bigger objects. In the console output you can spot the name of the object which caused the problem, if it appears. In the CVS there is already a fix for the problem and it will be included in the next version. If you hit the problem with the ACCC tool, please report it to the TORCS users mailing list such that we can help you and to fix it. Okay, back to the tutorial. Our file has been processed without any flaw. As next step, we open up the shadow.rgb file to fill it with white color. This enables us to create later a screenshot from the car on the top and to fill in the shadow correctly. As you remember, we got this shadow from the car1 stock 1, and so it does not exactly fit. Okay, let's save this as new shadow RGB file. As next step, I will edit the car1 stock 1.xml file to adjust some things to our tutorial car. This file contains the description of the car for torx. This includes the physical parameters and the graphical objects and more. So basically what we are doing here is we start out from a car1 stock 1 and then modify it step by step till we have the desired behavior, look and so on for the tutorial car. I start always from an existing file because this enables me to have something quickly running without the danger of the simulation exploding. Because the physical parameters are not validated, the simulation can just explode if you choose bad values. As first simple step, I adjust the car name for the model file name and such. Now I rename the XML such that torx can find it. In the cartut directory it will search for cartut.xml. And now we are ready to put the whole stuff into the torx directory. I do not clean up the directory beforehand, but this does not matter at the moment. Cars go into the cars directory. Amazing, isn't it? Okay, now I fire up torx and create the driver which uses our new tutorial car, and then I will run it on a track to have a look on it. In the background we have the console open. This is the black window. TORCS will report their information if something is wrong or if something interesting happens. Because we derived our car configuration from the car 1 stock 1, the car will be in the stock 1 category. Okay, ready to hit the road. In the first tries we will just adjust the collision bounding box of the car and the car axis. As you can see, there is a fuel warning in the console window. You can ignore this, but otherwise everything seems to be fine so far. First I show you how to check the collision bounding box. Of course this does not fit yet because we did not adjust it. I choose the top view and drive gently into a wall nearby, and you can see that the front of the car goes out of the track border actually, so the collision bounding box is too small. In the side view you can see that the axis needs adjustment as well. Okay, let's go back to the XML file and to adjust the axle position. I search for the axle section. Whoops, not case sensitive. As you might remember from the first tutorial, the center of the model was first off by minus 0.293 meters before we centered it. I told you there to note it down. Now we have to add or subtract it from the axle. We add it to the front axle and subtract it from the rear axle. Okay, this should do the trick. Then we need to save the file and to copy it into the TORCS installation, where we copy it before the whole bunch. As you can see, we did not switch off TORCS, but when it reloads the model, it will pick up the new XML file. Ta-ta! Cool, it fits. The next step is to fix the bounding box. So for that we load the model into AC3D, and there we can see the dimensions if we select all. Here in the top right corner it is displayed. I note it down and update then the XML file with these values. There are two sets of values to edit. The one defines the body size and the other the collision bounding box. But collision detection nowadays is such accurate that you can use the same values for both. You can see in the attribute above, the category, that this is still stock 1. This category will then complain about the car body length because it does not fit the limits of the stock 1 category. You can think of categories as templates which define value ranges for the actual cars which are of this category. So the category says the car is between 4.9 and 5.2 meters, and if it does not fit, it does complain. Okay, save, copy and test again. As predicted, you can see that there are some complaints about violated limits in the console. As quick workaround, we will put our car into the free category instead of the stock 1 category. You can find the available categories in the categories directory. If you want detailed control over multiple cars of a certain category, you can create an own category if you like. Okay, let's put this into the free category. Save, copy and test again. Okay, the complaints are gone, so let's check the bounding box with scratching along the wall. Great, the front fits exactly. Then let's check the rear. Yep, perfect. To check the width of the car, I will as well scratch along the sides. Okay, great. When the bounding box fits and the axes are adjusted and you have verified it, then you are ready to capture the texture for the shadow. Basically, you restart the race and take a screenshot from the top before the car has moved, so it is aligned with the track. To make a screenshot in TORCS, you hit F12. The screenshot goes under Windows XP, under the screenshots directory, in the TORCS directory under program files. Under Windows Vista and higher, it goes into the virtual store. Under Linux, it goes to your local.torx screenshots directory. So here it is. I just make a copy and put it in the working directory. Next step is to open up the file in the GIMP. Then I crop out the white rectangle. Then I make a selection on the white part with the color selection tool. And then I cut it out. Oops, I wanted it transparent, not black, so I have to undo it and to add a alpha channel first to the picture. And then to cut it out again. Now it worked. Now I do some manual adjustments. Now it is ready to be filled with black. For that I choose Layer, Transparency, Alpha to Selection. So the opaque parts are selected and fill it with black. Then I am applying some Gaussian blur to make the shadow smooth. Now I set the opacity to 80%. And finally I scale the image to the desired size. I usually take 256 times 128. The only important thing is that these numbers must be powers of 2 for textures. Then I export it as shadow.rgb. Same procedure as every time, copy the file from the working directory into the TORCS installation. And here is the fitted shadow. As you can see, because we set the opacity to 80%, we can see the street texture through the shadow. Shadows are not completely black usually. What you could improve is where the car rear goes up, that the shadow gets brighter, so you could improve that with the gradient. What we inherited from the car 1 stock 1 with the copy of the XML are the exhaust flames and the brake lights, but because these features are not on our car, we will remove those from the XML for now. I'm not yet happy with the inside view like it is. I will move the driver position a bit to the front such that this gray bar is not visible. Okay, let's open up the XML and fix these things. I move the driver position 0.3 meters towards the front. Okay, the inside view is great now. I like it like this. Then I comment out the light and the exhaust section. A final thing which I want to show you in this tutorial is what happens when the XML is broken. For that I break it here, so I remove some required stuff to close the tag and then copy it to the TORCS directory and run it. You can see that TORCS crashes. What is important here that you not just close the program but have a look at the console in the background, because there you can see parse XML not well formed at line 240. So this way you can get a pretty good idea what's wrong with the file usually. Okay, that's it for that part of the tutorial. In the next part we will test drive and adjust the car settings such that it gets a unique car. Currently it's more or less a copy from car 1 stock 1. We just adjusted the bounding box and the axis positions and some graphical elements, but otherwise from its characteristics it's still this car 1 stock 1. So we will adjust this then. Hope to see you then. Bye.